Pick Computing, A-Level Computing video 34. Here we're going to look at the CPU, the processor, and in particular the different units, the different parts of the processor and the different jobs that they do. The CPU, the central processing unit, we know this is the brains of the computer, and we don't just find them in computer systems that we're used to, personal computers. They'll be in all sorts of computers, including many devices around the home. So if we look at this image of a kitchen here, there are many devices, even in just this kitchen, that will have a CPU. We know they are very complex pieces of equipment. So that image there doesn't really do justice to the complexity of a processor. If we were to look at one underneath a magnifying glass, then we might see thousands of different wires that have been printed on to the device, thousands of different transistors and components that have been printed on there. If we looked under a magnifying glass, we might even be lucky enough to see what are called manufacturer Easter eggs, where they use the circuitry and design the circuitry to be able to create images, hidden images, but they can only be seen under microscopes. One part of the processor that you certainly need a microscope to be able to see is the processor clock. So a little bit about the processor clock first of all. Processor speeds are measured in hertz, Hz, and this is the number of times the processor clock ticks per second. Each operation takes a certain number of clock ticks to complete. Therefore, the faster the processor, the quicker operations are executed, and the quicker the computer will work. A processor with a speed of 300 Hz means that the processor clock ticks 300 times per second. 1 MHz, MHz, equals 1 million Hz. Therefore, a processor with a speed of 3 MHz means the processor clock ticks 3 million times per second. So we're getting very fast. A gigahertz, GHz, equals a billion Hertz. So a processor with a speed of 3 GHz means that the processor clock ticks 3 billion times per second. And we've got to bear in mind that a typical modern PC will have a processor with a speed of around 3.2 GHz. So most computers these days, the clocks in there are ticking at over 3 billion times per second. That's pretty fast. So the different units. Now you'd struggle to see the different units on the processor chip. It'd be almost impossible to make them out. But you need to know about them, and you need to know definitions for them. The first one is the CU, the control unit. Then we've got the ALU, the arithmetic logic unit, and the MU, the memory unit, which we also might know as the IAS, the immediate access store. First of all, the CU, then, the control unit. The CPU needs to execute program instructions. We know this. This is how computers work. The control unit does these particular jobs. It decides which instruction the CPU should execute next and fetches it from memory. It may need to decode each instruction. The instructions might be jumbled up, and it might need to put them in the right order, so it knows what needs to be done in order to execute the instruction. It decodes it. It sends signals to other parts of the CPU to tell them what they should do in order to carry out the instruction. And it synchronizes what is happening with all parts of the CPU by using signals from the clock. So that's the CU, the control unit. The ALU, the arithmetic logic unit, well, we know that the CPU is the brains of the computer. Well, the ALU is the brains of the brains. It is the brains of the CPU. It's the part that does the working out. It might also be known as the arithmetic and logic unit, and for good reason, because it does the arithmetic, it does the maths, and it also can do logic. It can compare values and return a result. That's why it's the arithmetic logic unit. It acts as a gateway between the CPU and all other components. And all input and output to and from the CPU goes to the ALU and waits until the control unit decides what to do with the input and output instructions. If this is sounding pretty complicated, and it can be, then what you need to do with these sort of definitions, rather than maybe trying to understand them, is just try to learn them. There's a difference, isn't there, between understanding how something works and then just learning a definition, memorizing a definition. So if you're struggling with it, memorize the words that are on here. The MU, the memory unit, also known as the IAS, the immediate access store, which we mentioned before, but we also might know it as main memory or primary memory. This holds and stores all of the instructions and data that the rest of the CPU is going to use. That's the definition of that one. Now, this is where things get a bit contradictory. The main memory is most likely to be your RAM, your random access memory, or cache memory. And we know that the RAM chip or even the cache chip will not be part of the CPU chip. They are separate things. For the purpose of the theory on this A level, we are considering main memory to be part of the CPU and the organization of the CPU, even though we know that in real terms they are two physically separate components. Now, there are lots of diagrams that might explain how information and data are sent around a CPU. So there's quite a simple one, although it's got some different terms in it we don't know about yet, like registers. There's a slightly more complicated one, and there is an extremely complicated one. Now, lots of different people will show lots of different things in their diagrams. Here's what I think is the best representation of what we've talked about in this video as part of a diagram. If we imagine the CPU component, in there we've got the control unit, which we've talked about, that does all the organizing, and that receives signals from the clock, so it knows when to do things, basically. In there we've got the ALU, the brains of the brain as well, communicating with the control unit. And the control unit will fetch and send data to and from our main memory, the memory unit. Notice that I put the memory unit in a different color there because it's actually a different physical device, even though it's part of the same theoretical device for the A level. Main memory in turn needs to get instructions and send instructions to secondary storage, the hard disk, because that's where the instructions originally live. And we know that as part of all of this, the CPU needs input and it needs output. Just to add a further bit of complication, the ALU itself will communicate with main memory, the memory unit, as well as a control unit communicating with main memory. So I just wanted to add that bit on there. Now, you may not need to be able to memorize or recognize a diagram like this for the exam, but you certainly will need to be able to cite definitions of the three main units. So the next 3 slides will briefly show those definitions again. So if you need to learn them, pause each slide, learn them, and then you'll be good for the exam. Control unit, arithmetic logic unit, memory unit.